Hi, welcome to video 28. This is another strings video and we are looking at validating string input. So the purpose of this video in particular is to be aware of and to be able to use Python's .is family of functions and to be aware of some additional approaches to basic validation of input. If you weren't aware, guys, it's very often the case that you will be expected to introduce some type of validation in the planning and coding of your practical programming project on your course. So you may find the scope of this video particularly useful for you. So guys, just a reminder that the Python Monster resources in the Schoology folder now have two PDF catalogues for the videos. The playlist and booklet view or PDF categorizes the videos into playlists and suggests an accompanying booklet or booklets that will go along with the topic of the playlist. The full catalogue is a more detailed description of the videos as they appear on the YouTube page, and these are in sequence order. So guys, let's crack on and do some validation Python demos. So there's no theory as such with this video. It's mainly introducing Python functions that are both useful for validating the contents of strings against some criteria, but are also pretty intuitive to use on their own as well. So on that basis, I thought it would be an idea to do another of those non-trivial programming challenges and present you with the solution for us to go through together. Personally, I think it would be useful for you to do this with me using the video because it gives you a chance to see an example of a solution to a non-trivial challenge, along with seeing the structure and sequencing of code as well, and also my explaining the logic behind the solution. Having said that, guys, there is a text version of the solution in the code example folder in with the Python videos on Schoology. So if you just want to download the solution, convert it to a python.py file and play around with it yourself in idle or PyCharm, of course you're welcome to do that as an alternative, or you can do both in fact. So if you're still with me, let's go through the family of .is functions, and you will notice by virtue of the name and what you're looking at on the screen that all of these functions in fact use Python's .function syntax, hence the nickname for them. So guys, here they are. So these are the main ones, or the ones that tend to get used the most frequently in validating. Is all num asks if or checks if characters in a string are all alphanumeric. So in other words, if all of the characters are either alphabetic characters or 0 to 9 characters. Is alpha checks if all of the characters in a string are all alphabetical characters. Is digit checks if all of the characters in a string are numbers, in other words 0 to 9 characters. These one, guys, fairly self-explanatory, but it is, again, it's sort of all or nothing really. So is upper checks if a string or the characters of a string are all uppercase. Okay, not some or many, but all have to be uppercase, so the entire string is uppercase. Is lower is the converse, checks if all of the characters in a string are lowercase. And is space checks if the string that you're looking at is basically just spaces and nothing else. Okay, so if it's a space, particularly useful for checking a character or for checking for leading or trailing spaces with a string. Now the others here, guys, you have to put in a parameter within the bracket. So I've given you an example here. Ends with P checks if a string ends with the character P, no surprises there. Starts with H checks if a string starts with the character H in that particular case. Now guys, there are no built-in functions to test for floats. Okay, if you wanted to do that, you'd have to write your own code, and it would be pretty complex to cater for all the different scenarios you could have with a string, which has to cater for different sizes of floats, including being surrounded by other characters as well. Okay, so Python doesn't have that. Surprisingly, however, there is an isDecimal function which doesn't check for a float. Okay, you're welcome to look up what that actually does if you want to, but it's not something which is intuitive by virtue of its name. Okay, it's not obvious. The other one, guys, is that's available to you is numeric, but you won't get any additional use out of that compared to is digit, which is the one that I've included further up. Okay, so let's go into the boxes and have a look at the particular challenges or challenge which I have set us to do. So our challenge is write a program to validate a password input. That sounds quite cool until you see all of the rules involved of the stuff that you've got to validate. So the password rules are: the password must be 8 to 10 characters in length inclusive, so 8, 9 or 10 characters. The words pass and word cannot be included in the password. The first 2 characters must all be numbers, so both of the first 2 characters in the password must be numeric. The last 4 characters must include at least 1 character that is not alphanumeric, and the first occurrence of an alpha character must be uppercase. So to make it a little easier, what I have done is I've put the criteria in the logical order that we would probably want to test to make sure that those are true, and to obviously to respond if they are not true. And you'll see a sense of that logic when we actually come to look at the code. So let's run it and see the type of output that we're going to get, and then I will go through the solution with you, okay, and then you'll have a picture in your mind of what the output sort of looks like when the program is actually run. Okay guys, so let's test our program by inputting some passwords and seeing what feedback we get. So I will put the password attempts in more or less to test the rules in order. So let's try length of password. Okay, so I put in 4, okay, and it won't accept that one. So let's try putting in something really long, which goes right out of the recording window. Okay, so same again. Okay, so let's keep to 8, 9 or 10. Let's pop in password. The length is okay, but obviously we're hoping it will detect pass and word. And indeed it does. Okay, so let's get slightly more sophisticated. I'm not sure whether anything here is going to be particularly sophisticated, but nevertheless, let's try and think of some more elaborate passwords. So let's do PERT 1, 2, and let's do a non-alphanumeric 34. Okay, so it says PERT, okay, which is the front end of our password, must have the first 2 characters as numbers. Okay, so let's do something that follows that rule. So first 2 must be numbers, so let's put in 34, and then PER, and then alphanumeric, and let's do 34. Okay, it says P must be uppercase in your password. Okay, so that relates to rule number 5, which is the first occurrence of an alpha character must be uppercase. So let's test that. Let's put in something a little bit different. So let's pop it in 6, 7, okay, P, so that will be the capital letter for our first alpha character, PETTRR, and it says TTRR, so that's the back end of the password, must have 1 or more characters, neither letters nor numbers. Okay, so let's see if we can hit this one on the head then. Let's do 67, so that covers the first 2 numerics. First capital letter for an alpha character, so that's capital P, and then let's put something else in ET. We want to have a non-alpha numeric character for the back end of our password, so let's put in something similar to what we had before, I think, and let's just wrap it up with 20. Password accepted. Okay, so does 67 PET and then percentage sign 20 work? Okay, let's have a look at the rules. Password must be 8 to 10, check. The words pass or word cannot be included in the password, check. Okay, the first 2 characters must all be numbers, check. The last 4 characters must include at least 1 that is not alpha and numeric. Okay, so we've got our percentage sign in there, so that's cool. That's within the last 4 characters. And the first occurrence of an alpha character must be uppercase, which is the P. Okay, so our code appears to be working okay, and it's accepted a password that agrees or follows all of those 5 rules. So what we'll do, guys, is we'll go through the code, and I'll start off by talking about the blocks of code, which is similar to what I did in the erase challenge. Excuse me, and then we'll dive down and we'll look at the code in a little bit more detail and see how it works. So I've zoomed right out, and I'm not expecting you guys to be squinting at the screen trying to read this stuff, okay? It's just to give you a sense of, if from a high level perspective, where the major blocks of code sit in our solution. So you could say that our first independent block, if that's the right expression, our first separate or independent block of code is really here. So this is the sort of setting the scene part of the program, really. So we're getting the user input, and we're initializing a variable, validated is true. Okay, and then we've got one constant to set a value for, which is len, which is the length of the user inputs. So that's our first, if you like, setting the scene block of code. Then underneath that, if I can just scroll down a little bit, see if I can fit all of this in. Yes, I can. So even though, guys, there's a little bit more underneath that, it's essentially comments only. So this, what you see in the recording window now, is the major mechanics block of code. Okay, so all of this is essentially doing our validation and checking that the user input is acceptable. Okay, so this is our machinery here within this big block of code. And then once we have moved down a little bit further, so let me scroll down. Okay, we've got a sort of wrap up block of code, if you like, which is down here. All right, so this is the block of code where you go, that's all of the heavyweight stuff done. We need just to send out a courtesy message to the user to say whether the password is accepted or not accepted. That is one of the reasons, guys, why right at the top we have a variable called, let me just get rid of that other box then. We've got a variable called validated up the top, and that is played around with in our machinery block of code, changing from true to false. If we have one of our rules violated, and then that variable is picked up and used again in our bottom block of code. Okay, right at the very bottom, this courtesy message that goes out at the bottom here. So that's why we have that variable called validated. Okay, it's made specific use of here. Okay, guys, so what we will do, I'm not sure there's much value to be had in exploring our introductory block, because you've seen that many times before. So let's zoom in and let's look at our huge mechanics block of code, and let's see how that works, because that's where all the validating is done with the there's one loop in there, and I think loads and loads of condition selection. Okay, so let's pop in, let's do a deep dive into that block of code then. So let's zoom in. So guys, the other reason why I put some of these rules together in the way that I have was because I wanted to try and give you a good example of what we really mean by sequencing. Now, I know I've mentioned this in the past, and I know that sometimes in textbooks on internet sites and on YouTube videos, basically the answer to the question what is sequencing is basically where do you put your code in order. Okay, and you guys, and myself included, will have sat there and thought, well, isn't that common sense? Because you're not going to put total equals and print it out if you haven't actually calculated the total yet. So I know that sometimes the definition of sequencing doesn't seem any more than common sense. So what I wanted to do was to put together a sort of trivial example of where sometimes people will go, damn, if I'd done that the other way around, or I'd put that block of code first, it would have made life easier. All right, and with more complex problems to solve, sometimes it's actually worth spending time thinking about the order that you approach particular little I guess you could call it decomposition, really. When you've decomposed your program into smaller parts, that doesn't necessarily mean that the parts need to be put together in some predefined order, and sometimes it can be well worth, with a bit of ingenuity, thinking actually if we combine two bits together and put that first, that works better than putting one of those second or third in our sequencing. So here's an example, and I know once I mention this you'll say, oh yeah, that's obvious, okay, but it's not always obvious until you sort of mention it. Okay, so what I've done, let me give you an example here, is, and I know this was the order that it was presented in, but it didn't need, the rules didn't need to be presented in that order. So what I've done here is, in this block here we've got an if-elif statement, and you can see, guys, that this is checking for rule 1, which is basically whether we've got an acceptable password length of 8, 9 or 10. Okay, and here we're checking to see whether or not there is an occurrence of the substring pass or an occurrence of the substring word in the user's password. Okay, question, why am I doing this first then? Okay, why would I do that specifically first? Why would I jump straight on the password length before doing anything else? Okay, well, the answer to that question actually is, underneath this we have a requirement to start splitting our password into two parts, because the rules specifically say the front end of the password needs to contain this and the back end of the password needs to contain that. The easiest way of doing that is to create two substrings. Okay, but there's no point in creating two substrings, okay, and doing the code, all of the code to put the mechanics of that in place if I haven't actually tested whether we've got a password long enough to split into two. So what happens if the user puts in a password with one character on in it? When we come to the bit where we're trying to split the password into two, it will come up with a syntax error. Okay, whereas if I check for the password length first and it's unacceptable, okay, then we never get to the bit where we actually need to bother with the 3, 4, 5 lines of code where we're splitting the password up in the first place. Okay, so this is a really good example, trivial though it may be, of actually thinking that bit needs to go first, because there's no point in doing the bit that follows unless the first bit is tackled and we've got some validation of that or some outcome from it. Okay, so sequencing is not just the common sense bit that says I need to get to an answer before I can print it out. It's actually about thinking of the volume of code that you might need to write if you put things in the wrong order, for example, okay, or the extra effort you're having to go through if you haven't thought about combining bits together and seeing whether you can sequence them in an even more logical order. Okay, so that was one of the purposes for putting things together in this order, so I can introduce you to a little bit of the thinking. Right, okay, so let's go back to where we were. Let's have a look at this bit here. So in the first bit, guys, we're basically, a lot of the time in this solution, we're testing for the negative, so we're testing for a fail. So what we're actually looking here is we're testing whether or not the password is actually greater than 10 or less than 8. We're looking, okay, for that to be true. Basically, if that's true, it essentially means that we have a failed password, if you like. And that's why, if that is true, then we're getting these failed messages. Okay, it does also mean, of course, that if this fails, then none of the rest of the if blocks are going to be executed. Okay, the program essentially it essentially goes straight down to the bottom part where we send out to the user that courtesy message in that wrap up block of code at the bottom. Okay, so the syntax to this, guys, I know you will find fairly straightforward. We've got comparison operators in here, and of course we've got a logical operator in the middle, which you have seen before, guys, and it's not the syntax of that, and the computational thinking is not that much different from what you would do in maths. Okay, now this one here is a little bit more interesting. I am using the Python find function. Okay, now the idea with the Python find function is that when it has found a substring within a string, in other words, it's asking the question, does my larger string contain the smaller substring? Normally, of course, that will pass back the value where it finds the string. If it can't find the substring at all, it returns -1, which is a typical error return code. So what I'm doing here is I'm specifically checking for occurrences where it's not -1, because I don't want pass and word to be found. What I want is for -1 to be returned, because it doesn't exist in the password. So I'm checking, guys, for it's a negative condition essentially here, and what I'm saying is one or the other needs to be true for that condition to fail, or for the password to fail. Okay, I don't need both. I only need an occurrence of pass, or I only need an occurrence of word in the password for either of those two to justify the password failing. Okay, so that's why it's got the logical operator or in the middle there, guys. Okay, and then of course for each of those validated is set to false. Okay, just to flag the fact that we've had a password fail. Okay, so let's move down to the next bit. And the next bit is basically saying, okay, we've got the easy stuff out of the way. All right, if all of those are true and the rules have been passed, then we've got to start to do a little bit more complicated code to split our password into two, so that we can work with the front end characters and the back end characters, because those two substrings have got specific requirements associated with them. Okay, guys, so this bit here, let's just pop a rectangle around this bit here. Okay, so this is the part of the code that's dedicated to successfully splitting the password into two. So how does this work then? Well, our password length is either going to be 8, 9 or 10. How do I know that? Because we would never have got to this part in the code if that had not been the case. Because if the password wasn't of 8, 9 or 10, okay, these would have been true, and the else block here would never have been actioned. Okay, so I can confidently know that in this code I'm going to have some sensibly lengthed passwords, or some sensibly long passwords to work with. Okay, so first question then, first length, guys, that's obviously the length of our first half of our password. Why have I used len, okay, integer division 2? I've done that specifically so that I don't end up with 9 divided by 2 is 4.5, because I can't work with 4.5. It's not going to mean any sense to me. I can only work with whole numbers. So this basically means that first length, if the length of the password is 8, then first length will equal 4. If the length of the password is 9, then first length will equal 4, and if the length of the password is 10, then first length will equal 5. And that's because I've used integer division, okay, signified by the use of the double slash there, guys. Okay, so I get a nice whole round number to work with. So in that case, logically, the second length must simply be the whole length of the password minus the bit that I've just calculated. So it's the bit left over, guys. Okay, now the next bit gives me essentially the actual characters that I need to populate with my lengths that I've just calculated. Okay, so the first half of the password, given the fact that I've just calculated what the numbers should look like, first half then I need to use slicing. So take the password, okay, and I want my conditions for slicing the password and creating a substring is I want to start at position 0. I want to go up to and including, sorry, up to but not including the number I've just calculated for first length in steps of 1. Okay, so that will give me the actual string value of the first half of the password. Okay, the second half of the password, I can slice that as well, and I can create a substring, which basically means, right, I need to start after this bit is finished off. So I need to start with first length, the value of first length, up until the end of the string, okay, in steps of 1. Okay, and that should work fine. So that will give me, having calculated the values of the length of the first and second password, I can now actually put that into action and create substrings with those numbers. Okay, so that's what that little block of code does there. Okay, so let's scroll down a little bit. Okay, so basically we've finished testing 3, 4 and 5 here. So this next little sub block of code, okay, we're testing for 3, 4, sorry, this is the block of testing for 3, 4 and 5. Okay, so this is the block here where we start to test for rules 3, 4 and 5. Okay, so rule 3 says the first 2 characters must be numeric. That's in the first half of the password, obviously. How do I test for that? Well, simply I want to slice, okay, up to but not including the character at index 2. Okay, so in other words, the characters at index value 0 and 1. All right, and having done that, I want to test whether it's numeric. Okay, so I'm asking the question, having found my substring, are the 2 characters at position 0 and 1, do they contain, both contain numeric characters? Okay, and if the answer to that is no, then we failed that rule. Okay, so then of course we print out our fail message and then we set validated to false, just as we have done in the past. Okay, let's have a look at test for 5. And now this one's a little bit more complicated because this is the test where we need to determine whether the first occurrence of an alpha character is uppercase or not. If it's not uppercase, then it fails the password test. Okay, so the first thing that we need to do, guys, and I'll explain this variable in a second, I've chosen to call this variable found first. Okay, and what this variable does is it basically flags whether or not we've already gone through this process and picked out and looked at the first alpha character. All right, that will become clearer in a second. So this is our count loop. We are looping from 0 through to the entire length of the string. Okay, and this obviously, guys, here, okay, we're looking for the first alpha character could be in either half of the string. Okay, either half of the password, I should say. So what our test says here is if the password at that particular point okay, in the string, that particular index, is an alpha character, we need to test whether it's uppercase or lowercase. Okay, and also this bit here is testing whether or not we have already gone through this process before. Okay, so hold on to that thought. Both of those have to be true. If I found myself an alpha character, I'm testing whether it's not uppercase. Okay, in other words, it's lowercase, but I've chosen here to focus on the negative. So if not uppercase, okay, then essentially we have a fail. All right, we need to tell the user that the first character must be uppercase. Okay, I set validated to false, but there's another bit here as well, where inside this if block of code and just before the outer block of code, I've set found first to true. Okay, why have I done that? Because in this loop structure, we will go to the first alpha character, okay, and we will test that. All right, if that happens to be uppercase, then we've passed, but the loop will continue to look for alpha characters. Okay, so we need some way in the code of saying once you've got to the first alpha character, you don't need to go any further. And that's what this Boolean variable does here. Okay, this basically says if this is true, it basically means we have already tested and found the first character, the first alpha character, so we don't need to test anymore. Okay, so it's specifically if on the first alpha character it passes because it is actually an uppercase, but then we carry on looping to look for more alpha characters. Okay, now in order that we don't just carry on looping for no reason whatsoever, there is a break statement here, guys, okay, which I'm sure you would have come across in the classroom or in one of the previous videos. And what I'm basically saying is, if it's the case that the password test has failed, or we've already been around this loop before, no pun intended, we've already been around the loop before on this, then we can simply break. We don't need to carry on iterating, okay, because we've done all we need to do in this section of the code. Okay, so what else have we got to do? Let's have a look a little bit further on. Okay, and that's basically it. So we have, by this stage, tested 1, 2, 3, 4 and 5. Okay, all we're left now is with looking at whether or not throughout our mechanics validated has actually been set to false. In other words, we failed one of these at the top there, and then we print out our courtesy message to the user. Okay guys, so of course you are welcome to go through the solution on your own. Of course you're welcome to pause the video and replay it if you want to spend more time studying this. Okay, you can also use my solution and see if you can improve it, because there's always more than one way to solve these types of problems, guys, and you may find an alternative solution which works well for you. So I hope that's been useful for you. Now in the next demo I'm going to show you some other useful techniques that you can use for validating input in addition to the .is functions that I've shown you here. So I will see you in the next demo. So one of the most useful features that you can use as an additional tool for validation is to use the Python in collection or in membership operator, and you've seen me do this in previous videos, if not in the classroom as well. We simply compare a value against a set or collection of other values. So how might we test this? Well, quite simply we would say, I'm just going to make sure that response is lowercase, guys. Okay, so let's say response becomes response dot, and I'm going to use casefold as the equivalent of lowercase, guys. Okay, so that makes sure that we've converted the user's response to lowercase if it happens to be uppercase. So let's say if, and then we want response is in, and then we want our collection to be, and of course we want A, and then we want A, okay, all the vowels, guys, obviously, and then finally U. So if that is true, then obviously the user has not given us a consonant. So an appropriate message might be print, okay, and then sorry, this value is a vowel, or something similar, guys. Okay, so I will just run that more out of curiosity than anything else. Okay, so please input a character that's a consonant that's put in A, okay, and that works okay. So what we can do then is we can extend this concept to include our own bespoke collections of values that we want to validate against. How might we create our own bespoke collections? Well, the obvious answer to that, guys, is to use the Python list, because that's the collection you are most familiar with. So we would create our own lists of individual values that we want to validate against. And so the next thing I'm going to do is to show you an example of how we might want to do that. So if you look on the screen, the code is asking Python to give me an empty list of no particular size, and then to populate that list so that there are 20 items in the list, all of which are randomly generated integers from 1 to 35 inclusive. So obviously, guys, I've got no idea at runtime what those values are going to be. Then we're going to ask the user to input a number from 1 to 50. We're obviously going to cast that to an integer type, and the idea here is that if the number that the user gives us is in that collection, then it's rejected as a reserved number. Otherwise, if it's not in that list, then it's an acceptable number or integer. Okay, so let's just wrap the code up for this. So I would say if num in, and then we want the name of our list. Okay, then print out an appropriate message. So print sorry, this is a reserved word, a reserved number rather. Okay, please try again. Right, else, and then we want the opposite, so number accepted. Okay, so let's just run that and see what we get. And because I've asked Python to print the list out, guys, we can do a direct comparison. So there's our list. Okay, so let's try with a number which we know is in the list. Let's do 13. Okay, sorry, this is a reserved number. Please try again. Let's see if we can spot an opportunity for a unique integer. So have we got, let's see, have we got 1 in there? I don't think we have. So let's put 1 in, and it says number accepted. So guys, a very simple example, but drawing your attention to the fact that when we validate against a collection, it doesn't have to be hard-coded literals in your code. We can be creative and innovative about where those collections come from. And hopefully that's given you some food for thought. So that's the end of the demo and this video. I hope it's all been useful for you, and I will see you in the next video.